Okay, so these are the variables that are given here. All right, what are we looking for? Determine the amount of force with which Chuck pushes downward. So you're looking at the force that he pushes downward along the handle of the broom in order to achieve this constant speed motion. Okay, what force is that? It says the downward force.
FG.
He's pushing. He's actually pushing. So this FA is actually going down like that, right? So I'm gonna redraw this one because the free body diagram is drawn always away from the object, right? So he's actually pushing this way. So if I were to redraw it, it's gonna go this way. We are looking for the FA downwards, which is FAY. Does that make sense? This is this pull. So he's pushing the broom.
The angle the same.
The angle will be the same, yeah. So I just kind of move this triangle over here. So that's what we're looking at, is this triangle right here. It's not in the floor. I'm just redrawing it.
You mean the picture is all the same as the graph?
The picture is because when you draw the free body diagram, you don't draw arrows into the object like that, right? So you actually draw it away from the object. So I just kind of redrew this. This is what he's doing to the object, to the broom.
Incline, it must be through the graph. Down.
It's not an angle. It's not an inclined plane. So this is basically what's happening. So I'm going to take the stick, a broom. I need the stick. So here's what's happening. I'm mopping the floor, right? I am applying a force to the handle of the broom. Like, pretend this is the floor because you can't see it. So I'm applying a applied force to the broom at 41 degrees to the horizontal. So when you draw the free body diagram, you're actually applying a force down, which is this, and to the horizontal. Your applied force is now split into the Y, which is the downward push, and the horizontal, which is the pushing across. Does that make sense? Okay? Every time you apply a force, there is an X and Y component separately. So this is what's happening. That's what we have. So if I were to now redraw this, so here's the broom. Okay, so you can kind of see where would the force be, the force of friction. So yeah, the FF, right? So if I were to just kind of redraw this right here, so here is the box. It's gonna go this way. Okay, the friction is actually going that way. So I just redrew my picture. So FAY, FAX. This is my FA. I'm looking at frictional force against that motion. So here is the motion of the broom. What is the net force equal to?
Resultant. Why? How can you say force?
The resultant is the actual applied force that you are pushing on the broom. That's the resultant. That's the total amount of force of effort that you're applying to the broom. I'm pushing down like that. My applied force is this. That's the hypotenuse. The resultant is the hypotenuse. So that means if I push this desk, I'm pushing down on it, and I'm pushing this desk that way. But my actual push is this, whatever my angle is. Does that make sense?
So what I'm going to confused in this graph is all the applied force is pushing.
The applied force is what you're actually doing. I'm going to redraw this again one more time. There's the broom. I'm going to push this broom into the floor. This is my applied force. Does that make sense now? That's the hypotenuse of the triangle. But this applied force is broken down into, I actually pushed down on it, and I actually pushed it across that way. Do you understand now? At an angle of 41 degrees. Okay? So when I'm pushing it though, there's friction. Okay? So that friction is going to the opposite direction. There's frictional force. The broom is actually going this way with some net force, which is constant velocity, which is 0. That's exactly what's happening in if you were to show what you're doing with the broom. There's the broom. The broom is being pushed down and across. Okay? Frictional force is fighting that, and you're moving the broom this way. That makes sense? You're mopping it. You're moving the floor. You're moving the mop on the floor like this. Okay, you got it now? Okay,
So
all right.
in this case, F net is equal to F,
That's what we're gonna try to write now. Okay, so the frictional force
how are you
is,
gonna write the equation of this?
okay, so this is a free body diagram. The free body diagram tells you what's happening. All the forces are here now, right? This is moving this way. This is moving that way. That's always a net force. So if that's moving that way, what is that? Is that a positive or negative? Net force always, 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 always 100% positive. Which means your applied force is positive because you're pushing the broom that way. That's how the broom moved, because you gotta push it, right? So your applied force is actually not going all into the x, but only Fa of x. Okay?
Which one is correct? Is this graph or this the first one?
This is the free body diagram.
Okay.
This is showing you all the forces and the broom. So this is actually kind of like the free body diagram too. This is also a free body diagram, but looking into the floor. Okay?
This is to the right side. That is the left side. Which one is first?
Because the object is the broom, right? Like you're not like pushing a box. So I didn't draw a box here because you're talking about the broom, correct? Talking about the broom. So this is, you can think of the box, there's the box. So there's your push, the object. When you push it, there's your applied force, okay? The applied force is gonna be fought by the frictional force, which is right here. I drew it down here because it's on the floor. I drew it on the floor. And then it moved, so this is the motion, so that's a plus. Fax is a plus. Frictional force is minus, right? Yeah? Okay? All right, so we're not looking at a box, we're looking at the broom here. So what is the net force equation?
Minus F.
That's a big difference there. You gotta put Fax minus frictional force. Okay, so this is in the x component. Okay? So this is equal to 0 because you're pushing the broom at a, I think that's the situation. I'll have to look at the question again. It is constant velocity, right? Let's double check. You are pushing the broom. Yeah, you're pushing the broom. There's a box. Is there a box? No, you're pushing the broom. Okay. So if this is the case and net force is 0, then Fax is equal to frictional force. And what are we looking for? It says we're looking for the downward, which pushes downward along the handle of the broom in order to achieve this constant speed motion. So we're actually looking at the downward force. We're looking at this one. It seems like we're looking at the downward force on the broom, the Fa of y. Okay, so this is the formula on the x-axis. What is the formula on the y-axis? So on the y, what do you have? You have Fay, but you also have gravity, don't you? Okay, so let's take a look at this. This is the part of the broom that is in contact. So I'm going to use that as kind of like our box in our free body diagram. Okay, this is the one that's making contact. Okay, it's really kind of complex. So this is the part. I'm going to use that as the box down here. Okay, so when you're pushing it like that, those are the ones that are making in contact. So this one has Fg. You guys okay with that? The broom itself, which not just that, but the actual broom has an Fg. Yes? But because it's touching the floor, it has Fn as well, yes? Okay, so let's take a look at the actual forces here. So, what are the forces in the y direction? Fg, Fn, and Fay. Fay is also there. Right? So I'm going to just combine these. So this will be Fay plus Fg minus Fn equals 0. Now I go, well, how do I know which one's positive, which one's negative? Well, the broom is going, you're applying a force down, aren't you? You're pushing the broom down. Let's take a look at the Fg and Fay. Are they in the same direction?
Yeah.
Yes, they are. So I added them together. Okay, so Fay, which is down, look at this, and then Fg, which is down. I combine the two, minus the Fn, which is the opposite. Is that okay? And that's equal to 0. So when you put this together, really it's Fay plus Fg equals Fn. So the Fn on that broom is really equal to the push that you're applying, the Fay plus the Fg. Does that make sense so far? All we're doing here, guys, is just writing the Fg, looking at the arrows, and adding the ones that are going in the same direction. Okay, so I'm going to rewrite the x and y components here, right? So the x component, we have Fax equals Ff. Okay? And in the y component, we have Fay plus Fg equals Fn. Alright, so what we're looking for is the Fa of y. But let's break it down because we need to combine the x and the y components here. Okay, so Fax. This is our triangle. We have a 41 degree. Do we know the Fa? Number 6, do we know anything here? Or what do we know? We know the frictional force?
We have mass.
Okay, actually we don't know frictional force, but we know the mu. Okay, so I'm going to just write down on the side here, frictional force is equal to mu F of n. That's always the formula for frictional force. Okay, but what is the F of n? We know the mu, it's given. What is the F of n in this case? It's right here.
Yeah.
We have to find it.
We have to find it first, right?
Yeah.
Fg equal to
So
Mg.
Yeah.
if Fg equal to Fn in this case? No, it's not.
So now we
No,
have
Fg.
mass.
He's saying how you find Fg.
We have mass.
We have the mass, right? So Fg we can find,
Yeah.
but can we find the Fa of y?
Not yet.
Not yet, right?
Yeah.
Okay, so let's actually figure out, because if we can figure out the, I'm going to have to put this thing here is the same as that.
Yeah.
So I'm going to put all these into there. Is that okay? Does that make sense? By substitution. We're finding a way because we have very little variable known.
Sorry for the interruption.
So I'm going to go mu.
From 12 to 1, Red River College will be in our student lounge. Come on down and find out about prerequisites, financial aid, award, and how to apply online. Come on down.
And Fax is Ff, so I can actually do this. Fax is equal to mu Fay plus Fg. Can we actually put some numbers into here now? Can we know the Fg? Yeah, that can be a number.
Yeah.
This can be a number. So let's start putting numbers here. So how do we find the Fax from our triangle? I'm going to redraw it here so you can see it. 41 degrees. Fax, Fay, Fa. Okay, so Fax is right here. We have a 41 degree triangle. Let's do some trigonometry. Okay, so what's Fax? This one right here. Fa cos of 41. Is that okay? Vectors, right? Fa cos of 41 is Fax. What is the mu? 0.45 times Fay is FA sine of 41 plus, what's our mg? I'm gonna calculate here on the side. Mg is, what's our mass? 1.1 times 9.8. Let's calculate that on the side. (10.78 newtons). I'm gonna just write down 10.78 right there. Okay, let's put numbers here. FA cos of 41. What is cos of 41? So this becomes 0.755 FA equals, I'm gonna just actually do this one inside first. What is sine of 41? This is 0.656 FA plus 10.78. Okay, what can you do next?
Calculate. Yeah, the FAs.
Yeah, you have the FAs, but let's clean this up a bit. This becomes multiplied to that. So times 0.45. We're just doing math now. 0.295 FA. Is that okay? Plus 10.78 times 0.45, right? Okay, you got to do this as well. So this becomes 4.851, and this is equal to 0.755 FA. Now, what can you find? FA. You can combine FA. So this minus that. So 0.755 minus 0.295, and what do you have? 0.46 FA equals 4.851. What's our FA? Sorry, 10.55 newtons. Okay, so we found our FA. That is not what we're looking for. So we got the FA. What we're looking for is the FA of Y, right? That's what we're looking for.
For downward.
Yeah, the force that's going down.
It means
FAY.
Not FAX, yeah?
No, because FAX is horizontal. You want to find what is, I think that's what the question, go back. Yeah, it says it's how much is Chuck pushing downwards on the broom.
Pushes downward.
Mhm.
So
FAY. So now we've actually included everything here. So what is the FAY? FA sine of 41. So 10.55 times sine of 41 should be 6.92 newtons.
So now we can find Fn. Yeah.
Now, on the answer for number 6, I only gave you FA. So that I didn't complete that. So here, guys, we found 10.6, right? That's actually not what we're looking for. We're looking for, okay, hang on. Determine the amount of force with which Chuck pushes downward along the handle of the broom. I may have been looking at how he's pushing downwards with his applied force, but I think I should find the FAY. That makes sense, right? Downwards. So he should be actually looking for the FAY, which is 6.92 newtons there. So that was not worded clearly. That was a tough question, right? You know what was the hardest part of that? Was figuring out what was happening with the broom, right?
If you like in the test,
Yeah.
it will take a lot of time.
Yeah. That's too many words. I usually won't ask you a question like that on the test. That's too many words.
That's why. Even that,
Yeah.
That's okay to start.
That's a lot of reading. Too much.
Yeah, that's okay to calculate it, but the main problem is to.
Well, that's the thing. That's what makes physics hard.
Yeah.
Is you actually pick a situation and get what is happening. That's the hard part.
That's why.
Yeah. If I give you guys this, that's the easy part. Math is the easy
Yeah, I
part.
know. So that's the.
That's not physics. You do that in math class.
Sometimes.
Yeah. Yeah. Math is easier than physics because we just use math.
It means the same that number.
So what is the trick, guys? You notice that we always combine X and Y, right? Because when you're looking at something at an angle, you have to incorporate the X and the Y components together. So What we did is we broke it down into x and y, and then we put it back. That's how you fix things, right? You look at your car, for example, something is broken. You gotta take apart the pieces first, fix it, and then you gotta put it back. That is how you do things. Make sense? Go have some Spider-Man.
There's like 3 left.
Right, it's yours. Should we look at number 5? Number 7 should be easier because it tells you the free body already. Did you guys try these ones?
I did nothing.
Yeah,
You
I did
try.
that.
You got. Michael tried it.
Yeah,
You
I
tried
did
number
it.
7.
Even I do, but
And?
little thing I didn't understand.
Which one?
In the calculation.
All right.
This one,
What are we looking for? We're
yes,
looking.
I check the
working.
log.
It's on now.
and
Okay.
this one's the log, so
Number
when you
7.
do- yeah, F net is equal to FJX.
Mm-hmm.
Then
Wait.
we do that instead
So
of-
F net is it just FG or there's friction as well?
yeah, you do that. F net is equal to FJX.
Yeah, so there's friction going down, right? And then this one here is what is happening. Lap bar and incline the track, determine force along the frictionless track. Is the track going down or up? It's going down. Okay, so it's going down. It's sliding down. It is a frictionless track. It's actually frictionless. What this? Can you guys read this one? What does that say?
F,
Is that
FT or F2?
is that FN?
Maybe it's F2 because
Yeah, that is the first
the
one.
downward is F1.
So this is normal force. I'm gonna have to redraw this. I don't. Okay, I
So
can't
that-
see it. I'm just gonna draw it.
The log is easy.
Okay, so what's happening here? The picture to me, I can't read the picture, so I'm gonna just draw this here, okay? So then what's happening inclined at 15 degrees, and then the net force and acceleration along a frictionless track. So this thing here is going down with an FG, and this is your FGY. This is the FGX, and there is normal force. Anything else, right? There's nothing else, and it's gonna slide down, so it's going to have net force this way. So what's your formula? Net force is?
Is equal to FJX.
That's it. There's no friction, right? Yep. And what are we looking for?
Then
So several things you're looking for. Normal force. Your Fn is your equal to Fgy. Guys, you gotta look at this. Fn is going up. What is balancing that force? The one that's going exactly in the opposite direction, straight down. So that's equal to Fgy. How do you find the Fgy?
but
Fg
for
cos theta. You just do your trigonometry. It's Fg cos theta, which is m times g times cos theta. Done. That's your Fn.
But yeah, our question is not become the FJY.
No, you have a very you have a lot of questions here, right? So one of them is Fn. Fn is equal to Fgy, and you're supposed to find the net force. Oh, that's what that is. They called it N.
So
Newtons. Oh, that's net force. So you're looking for net force as well, which is Fgx, which is Fg sine theta, which is mg sine theta. That's it. So that is how we can find the net force. So we have found the normal force. We have found the net force. What else? It says the perpendicular force. Perpendicular force is the Fgy. That's the perpendicular force, 90 degrees. So we found that. The parallel force, which is the Fg of x, we found that. So that's, and the force of gravity, that's easy. Force of gravity is mg. And then you gotta find the acceleration. How do you find the acceleration?
So it will be. So we have to.
That's it. Do you know the mass? Yeah, you do. Net force over mass is your acceleration.